Welcome to the DIY Honda Garage channel. The DTC P16F3 refers to a condition where there is low voltage in the starter cut relay 1 control circuit. This relay plays a critical role in the engine's starting process by controlling the electrical flow that enables the engine's starter motor to function. When the relay fails or experiences low voltage, it can hinder the starting process. The starter cut relay 1 is typically located in the auxiliary under-hood fuse relay box, and it interacts closely with the powertrain control module, PCM. When this DTC is triggered, it suggests that there are underlying issues with the relay circuit that need to be diagnosed and repaired. Accurate troubleshooting is essential to restore the optimal functionality of the starting system and to avoid further complications. The DTC P16F3 specifically indicates that there is a low voltage issue in the starter cut relay 1 control circuit, identified by the powertrain control module, PCM. This DTC is generated when the PCM fails to receive adequate voltage signals from the starter cut relay, which is essential in allowing the engine to start. The starter cut relay is responsible for regulating the power flow to the starter motor. Its location in the auxiliary under-hood fuse relay box is critical for proper maintenance and diagnostics. Understanding the role of this relay is pivotal, since it directly impacts the vehicle's starting capability. This error can be confirmed through diagnostic tools like Honda Diagnostic System, HDS. Several potential causes have been identified for the DTC P16F3. Firstly, a shorted wire in the STRY-align line could prevent the proper voltage from reaching the starter cut relay. An open wire can also cause a loss of continuity in the circuit, which would hinder normal operation. Additionally, a malfunctioning powertrain control module, PCM, may not relay the necessary signals to the starter cut relay, leading to low voltage readings. A blown fuse, particularly fuse number C31, which controls the starter cut relay, can also lead to circuit failure. Hence, all these components need to be carefully checked during diagnosis. The key symptoms associated with DTC P16F3 include the vehicle failing to start, absence of power to the starter motor, and the DTC being displayed on the diagnostic scan tool. A non-start condition is typically the most noticeable sign, as the engine cannot crank over due to the malfunction in the starter cut relay circuit. Furthermore, there may be unexpected electrical behaviors, such as dim lights or unresponsive electrical components. The presence of DTC P16F3 in the diagnostic tool reinforces the need for a thorough investigation of the starter cut relay and related wiring. Addressing these symptoms quickly helps in preventing further electrical failures. The first troubleshooting step is to conduct an engine start check. This involves attempting to start the engine to determine if it is operational. If the engine starts successfully, it indicates that there might not be an immediate issue with the starter cut relay. On the other hand, if the engine fails to start, it directs the technician to proceed with further diagnostics. Recognizing whether the engine can start or not is pivotal in either confirming the problem or verifying if it's intermittent. This step serves as a foundation in troubleshooting by differentiating between active issues and temporary glitches. In this step, the vehicle must be turned to the off position before moving to the on position. This ensures that the system is reset. After switching to the on mode, the technician should clear the DTC using the Honda Diagnostic System, HDS. Following the clearance, it's essential to recheck for any pending or confirmed DTCs. If P16F3 is indicated again, it confirms that the failure is replicated. If not, it suggests an intermittent issue and may require checking for poor connections or loose terminals. This step is vital for understanding the electrical state of the vehicle before proceeding. Step 3 involves checking for a shorted wire in the Stirling 1 line. This requires the vehicle to be in the off position and the starter cut relay 1 to be removed from the relay box. By jumping the service check switch SCS line with the HDS and disconnecting the PCM connector A, the technician can then check for continuity at specified test points. These test points include PCM connector number 3 to body ground. If continuity is found, it indicates a short in the wire, suggesting a need for repair between the relay and the PCM. If no continuity exists, the wire is likely intact, directing the technician to explore other potential issues. The fourth step is to conduct a starter system check. To do this, the vehicle needs to be turned on, and the transmission should be in park, P, or neutral. Using HDS, the technician must evaluate whether the current conditions match the specified threshold. This includes checking the starter cut control return signal. If the readings do not align with the threshold, it indicates that there may be other underlying issues that need addressing, especially concerning the engine's inability to start. This step ensures that the starter system operates within the defined parameters necessary for proper function. In this step, the technician verifies potential failure areas, in particular focusing on the PCM. Initially turning the vehicle to the off position is crucial before jumping the SCS line again. Disconnecting the PCM connector A is necessary to measure the voltage between test points. This involves checking the voltage from the PCM connector number 3 to body ground while the vehicle is in the on mode. If battery voltage is detected, this indicates that the PCM is functioning adequately. If not, attention must be directed to further diagnosing the fault or substituting a known good PCM to ensure the correct operation of the starter cut relay. This troubleshooting step involves checking for open wires in the STRL1 line. It begins with turning the vehicle to the off mode and removing the starter cut relay from the fuse box. The technician will then check for continuity between specified test points. This test assesses the condition of the wire between the starter cut relay and the PCM. Finding continuity suggests that the wiring is intact, allowing the technician to proceed to the next steps. Conversely, if there is no continuity, it identifies that there is an open circuit present, which would require repair work on the wire between the identified locations. In this step, the technician is required to check fuse number C31, responsible for the starter cut relay functionality. This involves inspecting the fuse located in the under-dash fuse relay box to determine if it is intact. If the fuse appears to be functional, the diagnostic process can continue. However, if the fuse is blown, it may indicate a short in the IG1 start cut wire between the fuse and the underhood relay box. Should this be the case, repairing the short and replacing the blown fuse will be necessary to restore the circuit. The integrity of this fuse is vital for the proper operation of the starter cut relay. The final troubleshooting step involves conducting an open wire check on the IG1 start cut line. This requires disconnecting the starter cut relay and using a jumper wire to connect the appropriate terminals to body ground. Following this connection, a continuity test between designated test points occurs. The aim is to confirm that the IG1 start cut wire has no faults. If continuity is confirmed, the issue may lie elsewhere, likely requiring the replacement of the under-dash fuse relay box. Alternatively, if no continuity is found, it suggests there is an open circuit that needs to be repaired. restoring the connections vital for starter relay operation. After completing the necessary repairs for DTC P16F3, it is critical to conduct a final repair verification step. This involves testing the engine to confirm that the issues related to the starter cut relay have been resolved. If the engine starts without issues and there are no new DTCs reappearing on the diagnostic tool, it validates the success of the repair efforts. Additionally, clearing any remaining DTCs is essential, as this ensures that the system is reset and ready for normal operation. A successful test would indicate that all components in the starting circuit function as designed, thereby ensuring reliability and performance. Preventive maintenance plays a crucial role in avoiding the recurrence of DTC P16F3 and ensuring the long-term reliability of the starter cut relay system. Regular inspections of wiring and connections can help identify wear and tear or potential shorts before they become major issues. Similarly, checking the functionality of fuses and relays can prevent unexpected failures. Replacing any worn components promptly can enhance overall vehicle performance. Moreover, maintaining clean electrical connections will improve the reliability of the starter system over time. Embracing a proactive approach to vehicle maintenance will extend its life and enhance the driving experience. In summary, DTC P16F3 alerts technicians to issues within the starter cut relay 1 control circuit's low voltage condition in Honda Pilot vehicles from 2016 to 2022. It requires careful diagnosis since various factors, from shorted wires and faulty fuses to PCM malfunctions, can contribute to this DTC. Observing symptoms such as the engine not starting and voltage discrepancies provides immediate indications of underlying problems. Following the structured troubleshooting steps allows technicians to pinpoint issues effectively, ensuring that repairs are executed accurately. Moreover, preventive maintenance can help mitigate potential future problems. A thorough understanding of the starter cut relay system is essential for resolving DTC P16F3 successfully. Please like and subscribe to the channel. See you next time.